Hi guys, this is the next video, Docker Registries and Volumes. In the last video, we looked at building Docker images. In this video, we're going to take a look at different types of registry. We will also see Docker volumes. Docker is interesting for running applications, but it is also a very interesting choice to create command line tools that other developers can benefit from. In order to distribute images, we have to rely on exporting or importing the image or using a registry. A registry is basically a software that allows us to store and distribute Docker images. There are two types of registries, namely public registries and private registries. Let's take a look at the different registry types. First, we have the public registries. The most known of the public registries is Docker Hub. It is the official and default registry that every Docker installation knows of. Also, it offers private repositories, but the most interesting feature is the fact that all the official images are available on Docker Hub. Let's see how we can use it. First, you need to create an account. Once we are registered, we will create a new repository. This repository hosts an image called Modern DevOps. We're going to push one image into it. Here, we will enter all the required fields. Once it is created, you can see that Docker Hub suggests that you pull the image with this highlighted command. In your case, packed will need to be replaced with your username. Obviously, we're not going to pull an image that is not there yet, so let's push an image. Previously, we had created an image called My Node App. We're going to use this image to test Docker Hub. Docker relies on a tag system to know where to push the image or where to pull from. As we are working with the default registry, we don't need to specify the URL, but we need to specify the user and the repository name. Let's run this command. And then we will run the Docker push command. After a few seconds, our image is available on Docker Hub. As we marked it as public, everybody can pull and use our image. Now we move to private registries. But what happens if we want to store our images in our private registry within our infrastructure? Well, we have some options. If we're using cloud providers such as Google Cloud Platform or Amazon Web Services, they provide a Docker registry that is only accessible from within your account, and you can specify the region in which your images live. In AWS, the container registry is called EC2 Container Registry, and in GCP, it is called a container registry. If your infrastructure is one of these private clouds, I encourage you to use it as you can leverage the access to the access controls provided by the platforms. Sometimes we might find ourselves in a situation where we cannot use a cloud provider as our system has to be built on premises. This is when we need to use a private on-premises Docker registry. From all the range of registries, there are three that I find particularly interesting. The first one is
Quay.
This is a complete registry in the current market. It has some interesting features, but the one that is probably the most interesting is the ability to scan the images searching for security vulnerabilities in the installed software. The next one is Registry. This is the plain name for a plain concept. It is the official implementation of the Registry API and comes packed in a container. It has no interface or access controls by default, but it does the job. It also provides the storage management drivers so we can deploy our images to S3 or Google Cloud Storage buckets, as well as many other options. Registry is free and can be pulled from Docker Hub. The last one is Docker Trusted Registry. This is part of the enterprise version of Docker. Like pretty much any other commercial registry, it provides static container analysis as well as storage management drivers. Docker Trusted Registry is not free, so a license has to be paid for in order to use it. Now, let's move to Docker volumes. An important part of any application is the storage. In general, Docker applications should be stateless, but with the new orchestration software, more engineers are moving toward containerized databases. Docker solves this problem in a very elegant way. You can mount a folder from the local machine into the container as if it were a normal folder. This is a very powerful abstraction as it leverages the ability to push data out of the container to be saved into a network-attached storage or any other storage technology. Let's start with the basics. We will just run a MySQL database. This works. It actually does what is expected. It launches a container with a MySQL instance in it. The problem is that all the data is going to be written to var lib MySQL, and this folder is mapped to the top writable layer of the container. The only way to save data is actually committing the changes and creating a new image that is not manageable, and of course this is not the only way you want to do it. Think about it. If you remove a file in Docker, you are doing it in the top layer, which is the only one writable. So in reality, you're not removing the file, you're just hiding it. The file is in one of the layers using the space, but it is not visible. Docker records differences, and a layer itself is a set of differences from previous stacked layers. Instead of committing the changes into a new image, we're going to mount a folder from our Docker host into the container. Let's alter the Docker run command a bit. Now we have a new flag, -v, followed by the data value. The meaning of the command is very simple. Mount this folder into this path of my container. As you can guess, the data folder, in my case, it should be present in your current directory. So if it wasn't present, create it or modify the path to suit your setup and launch the container. This use case can only be achieved through the -v flag. Mount a selected folder from the host into the container. Now we execute ls inside the data folder. As you can see how MySQL has actually written data files corresponding to the databases created in Bootstrap. Docker volumes are not limited to one per container, so you can replicate the -v flag as many times as you need in order to match your requirements. Another way of mounting a shared folder between the container and the host is just specifying the path inside the container. For that, we run this command. This command will mount a folder from our Docker host into the container. The folder in the Docker host will be managed by the storage driver and Docker itself. Let's run the docker inspect command. The output is familiar, but now we're looking for different information. We are actually looking for a section called mounts, which looks like this. This is also possible through the volume instruction in a Docker file. The JSON is telling us which local folder is going to be mounted in the container and provides an interesting insight. The volume has been named by Docker. This means that Docker tracks the volumes that are mounted in any container and can be listed through an API call. Let's run the docker volume ls command. This output should be produced. We can also create volumes through an API call using the docker volume create command. This volume is created in the same way as the previous example. It is up to Docker to decide which folder on the local machine is going to be mounted in the specified path in the container. But in this case, first we are creating the volume and then mounting it to a container. You can even inspect the volume using docker volume inspect command. It will give us this output. Now we use this named resource and mount it into our containers, just referencing the name. The last interesting use case in volumes helps us share the configuration across different containers. Just imagine that you have a fairly complex setup that leads to a gigantic Docker command with several -v. Docker provides us with a much simpler way of sharing volume configuration across containers using this command. This is very simple and intuitive. MySQL 5 will spawn with the volume configuration of MySQL 4. In this video, we've looked at Docker registries and volumes. In the next video, we will see Docker networking.